think this should be an interesting video for determining power on any device, really, not just fish finders. We have Lowrance Hook2 on the bench today. We've never worked on the Hook2 line before. This is the first, so we're not sure what the power pinouts are. Obviously, we don't have the power cable. Customer didn't send in the power cable. So we're going to get this on the bench and kind of go through how we determine where to even apply the power. That's the very first thing. You can't even test the unit unless you know what the positive and negative pins are on the connector. And that's you don't want to swap them. I mean, we're here to repair it. We don't want to toast it. So let's get it on the bench and let's check this out. All right, so we're going to start taking this guy apart. Before we can do anything, we actually have to take the apart and figure out which one of those pins in there is positive and negative. So let's go ahead and do that. Okay, so we have the back off this unit here, and we notice that there's these two connectors here, top and the bottom, which actually make contact with the pins inside the back case. These pins are physically installed in this back case. Now, the top connector, it looks like all the pins are inserted into these holes in the connector. So it's just basically extending the connector through the case, external to the case. So you can plug the cable in there. Now the bottom, there's only two pins. I don't know if, let me get it under the microscope so you can see this real quick. Let's see. Yeah, there we go. So there's only two pins. And they're fairly close together, these two pins. So if you come over here and look at this board, let's get this under the microscope also. Okay, which one is this? Okay. So, let's see. Give me a quick sec here. Okay, so this is the bottom connector. Now, there's only two pins on the case, and the pins are very close together. Just visually, I didn't measure it. I didn't check with the caliper or anything like that. So, just visually, to me, it looks like the pins are like the distance, either the top or the bottom here. Absolutely, it wouldn't be from here to here. The distance is just too large on this connector to line up with the pins in that case. So just looking through the microscope, I mean, it appears that there's contacts in this pin, or this hole, and there's contacts in this hole. There's contacts in this hole, in this hole. Now I'm going to rule out these two right off the bat because it's just physically not going to fit, which leads me to believe it's these bottom two. Now, what I did, what you probably saw me, earlier is I lined up the case, sort of just visually eyeballing where those connectors are going to sit. And it looked to me like they would indeed sit right here. So our job right now is to find out which side is ground and which side is positive. So, okay, let's find a good solid ground on this board that we know for sure it's ground. I mean, 100%. Well, how would we find ground? The large portions of the circuit board have what's called a ground plane. So that would be one way to find ground, right? Like this side is the ground plane, it looks like, because these capacitors, one side of the capacitor is going to ground. Let's take our ohm meter. We're going to put it in continuity mode, so it's going to beep when there's a short. If you could hear that. Another excellent indication of ground, not all the time because sometimes it can be isolated, but usually, large portions of exposed metal, like for instance, there'll be a shield on the LCD. That's going to be ground. So let's just test that theory real quick. Let's, I don't know if we can do it with the microscope on. Well, I don't know. Let's see. Okay. It would make sense that this is also a ground. This screw hole here. That's actually not used, but it's a tinned hole. Okay, so it is ground. Okay, so let's check this out. Let's find a cap close to here. Oh, whoa. Okay, beautiful. So I'm going to say that most likely this side of the capacitor is ground. Let's get the fuzz off there. This side of the cap is ground. Well, let's touch this and find out. I don't know if you can hear that beeping. So that is indeed ground. So, okay, good. So our theory that one side of that cap is connected to ground is correct. So let's, and the other side is not. Okay, so it's the cap just charged, so it beeped. Okay, good. So now we have a point of reference for ground here. I am going to switch back to the other view. Give me a quick sec. Okay, so we're switched back to the other view so you can kind of see what I'm doing here. Okay, so this is the shielding I was talking about, this metal shielding here. This is going to be tied to ground on the board as well. We can also test that by going to that screw hole. I don't know if you could hear that. Maybe we can get this thing in view. This fish finder's a monster, so it's huge. So OL, it's open, right? Put the leads together. It's shorted. So there's continuity. There's continuity between the leads. Obviously metal to metal, continuity. Now what we already determined was ground, let's try that. Same. Okay, so we could actually test it from this shield. It might make it a little easier. So just touch anywhere on this metal and we could find ground. Ground. The other side of those caps we were talking about, ground. Even these two exposed copper circles here, pads, test points it looks like, ground. So there's many places we can find ground, so that's not a problem. So now, simple, all we want to do is touch one side to our known ground, and we're going to go to this connector. Now we believe it's these two pins. So let's check the left. No beep. There's no beep on that left pin. Let's check the right. There's a beep on that right pin. So we determine that the right side is ground and the left side must be power, right? So in this case, the right side is ground and the left is power. What I'm going to do, just because I'm not familiar with this unit and I don't want to forget and swap my ground for my power and toast the power supply or toast anything, I'm going to mark this. I'll just yank this off afterwards, but so I'm going to mark this. So just to double check again, no beep. Beep. Okay? Right side, ground. So let's find a pen or something. Let's see. Come on. Let me go grab a pen real quick. I'll be right back. Okay, so the right side is ground. So we're going to put GND in plus 12. Can't really see it, but it's hard to see with the light. There. Okay. And just a triple check. Just right ground, right? And that's what I wrote. Perfect. Okay. All right. So based on that, let's try to power this thing up. So I don't have any connectors made up for this because this is the first time I've ever had this unit in, or a unit like this in, this style power connector. So let's make some test power leads real fast. Okay. Got some more that should work pretty well for us. Let's see. Okay, we're going to tin these wires real quick. We're going to solder them onto that 2-pin header I stuck over there, which just fits perfect. Like it was made for it, perfect. So it's going to work out great. Tin the header real quick. Good. Again, right side right. Yep, right side's ground. Okay. That's good. tin this side. Okay, now let's see if we're right here. Fingers crossed. And again, you can easily insert this the wrong way. So we want to make sure the black wire, which is going to be our ground, is on the right side of that connector. Just like that. Make sure we're at 12 volts. In my case, just I happen to have the clip bleed set up like this. White is my positive, green is my negative. And if we determined our polarity correctly, again, there's an issue with this unit from the customer description, I guess, backlight, but we're going to know immediately if this thing is going to power up. We should hear a beep on my amp meter on my power supply. I'll see it spike up to an amp and a half. And 3, 2, and there it is, guys. And we actually have backlight, which is strange. So that's how you determine polarity on a connector that you've either never seen before. You don't have the proper power cable. I'd recommend buying the proper power cable if at all possible, but if you're repairing these things or in a pinch, I suppose you could use this method to determine what side is positive or negative. Well, backlight seems okay, but it looks like touch is not working. So let's see. Turns on, but no backlight. Unit is on because it beeps. Buttons are pushed sometimes. So customer doesn't say anything about touch. Well, I suppose this unit has to have a touch screen in order to be touch sensitive. Is this not touch? Again, we've never worked on the Hook2 before, so give me one sec. Well, guys, good news. I don't see any touch connectors here, which means obviously this unit is not touch. So for that accept button not to work when I'm touching it is good. That's fine since it's not touchscreen. Okay. In any case, this does look okay. The backlight is definitely working. Now let's try. The customer said when they adjust the brightness, it goes black. So let's try that right now. So I mean, it does seem to be working okay. What I'm going to do, a lot of times with these Lowrance units, the backlight circuit gets heated, gets hot. Normally, we've seen in the past those Schottky diodes heat up. Once they get to a certain point, they start failing. So let's just let this guy sit on the bench for like 5-10 minutes, see if something heats up, see if this backlight does go out. So we're going to kind of put it through its paces and test it. I'm also going to reach out to the customer, let them know that the backlight is indeed working for us right now, just to let them know. just give them a quick update. We try to update customers as much as we can. We do get inundated with repairs, and sometimes it's a little bit more difficult at times, especially when we have on-site work we gotta go to. In any case, we're gonna give the customer a quick call or shoot them an email, touch base with them, and we'll get back with you. So we did get a hold of the customer. We asked them if the backlight was intermittent or it was just constantly not working. They said it was not working continuously, so it wasn't an intermittent issue. It just wasn't working for them. And every time, consistently, when they would try to turn the backlight up, it would go completely black. So we were checking connections here, wiggling backlight and everything, and we were able to reproduce the problem where the backlight stops working. So we were troubleshooting, and we actually, on the back side of the board is the LED driver for the backlight controller chip. TS61, what is it? TPS 61194 is the chip, and we resoldered that chip, and it seemed to resolve the issue. So it looks like maybe there was some cold solder joints on the backlight driver chip, which we haven't seen before, but I mean, it's possible, and apparently it was the case here. Otherwise, the board looks super clean. There's no corrosion, no water damage, anything like that. But we're looking good, and we can't reproduce the backlight issue anymore, which is a good sign. So we're going to put this thing back together. We're going to continue to test it. We're going to continuously on, off, testing the backlight, increasing illumination, decreasing. And then once we finish testing it today, we're going to invoice the customer, send it off, and this one's done. So anyway, I hope the tips in the beginning of the video regarding finding positive and negative lines on a device was helpful. If you have anything that needs to be repaired, we repair fish finders and all other electronic devices, including laptops, tablets, cell phones. We do custom projects. www.rudolphrepairs.com. You can email us, rudolphrepairs@gmail.com. The 800 number is 1-800-517-9101. 517-9101. All right, guys, talk to you soon.